Okay, so in this video we're going to look at linear patterns, and we're going to look at a practical example of linear patterns. What we're going to do is we're going to look at a tank of water. It has a capacity of 50 litres and it's leaking, so we have water leaking out here somewhere. So initially at time zero it has a capacity of 50 litres, and each hour then it loses so much water. So it goes from 50 litres, and then after the first hour it goes down to 47.5 litres. After 2 hours it's down to 45 litres. After 3 hours it's down to 42.5, and so on and so on. So what I've done first of all is just drawn a graph of this data here. So along the x-axis here I've got time in hours, 1 up to 8, and on the y-axis here we've got the volume from 10 up to 50 here. Okay, so you can see that it's losing water regularly. It's a straight line, so it's losing the same amount of water each hour. So if we look at our sequence of numbers here, 50, 47.5 and so on, if we just take this value here and this value here, these values and so on, how much is actually being lost every hour? Well, if we subtract these two, it's actually going down by minus 2.5 litres. Same here, minus 2.5, it's going down by minus 2.5 and minus 2.5 here. So it's the same. It's the same the whole way down along. It's losing 2.5 litres every hour. So what we're going to do is look at deriving a formula for this straight line, or a formula to represent this whole sequence of events. So there are two ways of doing it. We're going to look at the first way by looking at this line here and deriving a formula or an equation of this line. So how do we do that? Well, it's a straight line, so it's going to be in the form y is equal to mx plus c. M is going to be the slope of this line, and c is where this line cuts the y-axis. So y here is going to be the volume, that's what's on the y-axis, and x here is what's on the x-axis, which is the time in hours. So let's have a look. The only two things we need to put into this formula here would be m and c. So we need to find the slope of this line, and we need to find where the line cuts the y-axis. So y here is our volume, so I'll just put in v for volume. M is the slope, we'll have a look at that in a second. X is going to be our time, I'll put in t for our time, and c is where it cuts the y-axis. So m here is the slope of this line. Now the slope of this line is really what it is the rate of change of the y-axis compared to the x-axis for every 1 unit of the x-axis. So 1 unit of the x-axis is 1 hour, each hour. So we want how the volume changes per hour, for every hour. So let's have a look at that. How does our volume in our tank change every hour? Well, it goes down by 2.5 litres every hour. So it's minus 2.5 t. Minus 2.5 is our slope. It's a negative slope, and it is it's negative 2.5 because we're losing 2.5 litres each hour. So all we have to do then is just fill in where the line cuts the y-axis. Now the line cuts the y-axis here at 50, so c is 50. And this is effectively our equation that represents what's happening to the water in this tank. The volume is minus 2.5 times the time plus 50. Let's just see, does that work? We'll just pick one of these data pairs here and see, does it work? Well, let's pick, let's say pick the second hour, for example. Okay, so we want to know what the volume will be after 2 hours. So let's see, does that actually work for us? So what we're going to do is put 2 hours in there for t, because we want to know what the volume is after 2 hours, and see, do we in fact get 45? Well, our volume will be 2 times minus 2.5, which is minus 5, plus, that should be 50, and that gives us a volume of 45. So we do actually get 45 when we put 2 into our formula here. So after 2 hours, the volume is 45. So we can use this formula here to determine the volume at any particular time. Okay, so that's one method of developing a formula to represent what's happening to the water in the tank. Let's have a look at another way. Okay, so what we're going to do is look at this sequence of numbers here, and we're going to work out a formula for Tn, any particular term number. This is term 0, this is term 1, this is term 2, term 3, term 4, 5, 6, 7, 8, and so on. We want to find any particular term Tn. So how do we do that? Well, what you do first of all is you just look at what the first change is or the first difference is. And in our case it's minus 2.5. Our difference between any two consecutive numbers is minus 2.5. So what you do is you put that difference in here and multiply it by n. So whatever your difference is in your sequence of numbers, it's that times n. Now, we want to add something here, probably, or we're going to work out if we do need to add something here. We can see from up here we do, in fact, need to add 50. So let's just look at what we've got here so far. Well, we have Tn is equal to minus 2.5 n. So let's check it out and see what happens if we just assume that this is our formula. So let's look at T0 when n is 0. So at T0, we should have a volume, we should end up with 50. Our T0 is 50. So let's put 0 in here. Tn is minus 2.5 times n. So T0 will be minus 2.5 times 0. So 2.5 times 0 is 0. Now, T0, our term 0 is not 0. Our term 0 is 50. So what would we have to do here to make that a 50? We would have to add 50. So we would have to add 50 here. So our formula is Tn is equal to minus 2.5 n plus 50. And that will give us an answer of 50 if we put 0 in. Try it for T1. If we put 1 in here instead of n, so we're looking at T1, that will give us minus 2.5 times 1 plus 50. That gives us minus 2.5 plus 50, which will give us 47.5 liters. So is our T1, is our first term here, T1, 47.5, T1 here is 47.5, so that works. So this here is our formula. Very similar to this one. It's the exact same as this one up here. Okay. So from this then we could change the Tn and the n to, we could change the Tn to V and the n to T. So Tn would be our volume and n is our time, to make it look like this to represent this particular problem. Okay, so now that we have a formula for volume and time, what we can do is answer further questions about this particular situation. So let's have a look at our formula again. Our formula is V is equal to minus 2.5 times T plus 50. Now a question we can be asked, we have two variables here. We have a volume and we have the time. So a question could be, you know, you're given a particular time and you have to work out what the volume would be at that time. So you stick T in here, whatever value you're given for T in here, and you work out the volume. Or you can be given the volume and asked what time would the volume be, at what time would that volume be. We'll do an example, I'll show you exactly what that means. So let's take, say for example, a question that would, let's see, be phrased like, let's say, what would the volume be after 6 hours? We'll take that. Okay, so the volume would be minus 2.5 times 6 plus 50. So what we're doing here is working out what the volume would be after 6 hours. So if you do that on your calculators or whatever, you'll actually get 35 litres. So multiply 6 by minus 2.5, subtract from 50, or add your answer to 50, and you'll get 35 litres. So our volume after 6 hours will be 35 litres. Now another question you could be asked would be, how long does it take for the tank to empty completely? Now for the tank to empty completely, the volume would have to be 0. So if we write down our formula again, V is equal to minus 2.5 T plus 50. Now our question is, how long will it take, or what will T be when the tank is empty, for the tank to empty? So in other words, volume will be 0, and we'll have minus 2.5 T plus 50. So our volume is 0, we've got to work out what T is. So what I'm going to do then is just try and isolate T. So bring this plus 50 over to the other side of the equation, or subtract 50 from both sides. You get minus 50 is equal to minus 2.5 T. Now we want T on its own, so this minus 2.5 is multiplied by the T. So we're going to divide both sides by minus 2.5. That will give me a time of 20 hours. Divide minus by minus, you get plus. 50 divided by 2.5 will give you 20. So our time will be 20 hours. So it will take 20 hours for this tank to empty completely, as it's reducing by 2.5 litres per hour. It'll take 20 hours in total for the tank to empty.